Hey, and welcome to the channel. Today, we're exploring how the humanoid robotics race is rapidly shifting from just building mechanical bodies to perfecting integrated AI brains. You know, for years, the ultimate challenge was just getting a robot to walk across a room without completely wiping out. But now, well, the hardware has really matured, and the entire race is all about embodied intelligence. It's about giving these machines the cognitive architecture to actually understand, process, and interact with the world around them in real time. We have a packed explainer today, touring 3 major international updates to see how different regions are solving the exact same massive technological hurdles. We'll be looking at China's split-brain Pi, Vietnam's dual strategy, Nvidia's open platform, and finally, the future of embodied AI.
So let's kick things off with Part 1, China's split-brain Pi by Jaka Robotics.
Over in Shanghai, Jaka Robotics just unveiled a compact 4-foot research humanoid named Pi. And right away what you'll notice is that Pi is a major departure from those massive human-sized machines we usually see dominating your news feeds. This is a highly versatile platform built specifically for embodied intelligence, motion control, and human-robot collaboration. Pi weighs in at just 92 pounds and utilizes 27 degrees of freedom across its body. Now, this incredibly sleek profile is made possible by these newly developed integrated joint modules that are up to 27% smaller than Jaka's previous generations. And honestly, that size reduction is a massive deal. Smaller joints help the whole body become lighter, cleaner, and just way easier to maneuver, all while still delivering enough torque, up to 88.5 pound-feet in the knees actually, to ensure stable walking and controlled locomotion.
What's really fascinating here is how this perfectly illustrates Pi's unique two-brain architecture. It literally separates the complex logic of understanding tasks from the deterministic, real-time physics of moving the body safely. Built on Intel's heterogeneous computing platform, the cerebrum handles all the high-level stuff: AI reasoning, vision perception, large language models. Meanwhile, the cerebellum handles the low-level motion control through an EtherCAT-based network with millisecond latency. Why does this matter? Well, a humanoid needs to understand a complex spoken instruction and then instantly translate that into perfectly timed, coordinated physical movements. If there's a lag, the robot falls over. It's that simple.
For Jaka, this represents a huge evolutionary shift. They're moving away from their traditional roots in automated industrial cobots and just diving headfirst into flexible, dynamic, embodied AI. You can really see a clear progression in their history. You had the Zeus series for assembly, the Pro series for harsh environments, and the S series for high-accuracy force sensing. Now, Pi takes all of that incredibly hard-earned manipulation hardware experience and combines it with machine vision, large language models, and real-time planning to create something entirely new and adaptable.
Moving right along to Section 2, Vietnam's dual strategy and the Vin Group ecosystem.
So, shifting our focus to Vietnam, we saw a surprisingly broad double entry into the humanoid space at ICRA 2026 and Computex Taipei 2026. This is all driven by the massive Vin Group ecosystem. Instead of testing the waters with just one generalized robot, they're aggressively attacking 2 distinct markets right out of the gate. Check this out. Vin Dynamics is targeting the highly unpredictable service and household sectors with a robot named Dino. Then, on the completely opposite end of the spectrum, Vin Robotics is focusing on heavy industrial manipulation, payload handling, and assembly support with a rugged, heavy-duty unit called the VRH3.
Now, the really cool part about Dino is the testing environment. They actually tested Dino outdoors, among crowds and noise, at the Vinpearl Safari Phuquoc. And guys, testing outside exposes navigation and perception weak points far faster than any clean lab environment ever could. Any robot can look incredibly impressive in a sterile, perfectly lit lab, right? But an outdoor safari? You've got sudden lighting changes, completely unexpected human behavior, overlapping background noise, and varied terrain. During this pilot, Dino had to use multilingual speech and real-time environmental awareness to guide actual visitors. It proved that its navigation and interaction systems can absolutely hold up in the messy, chaotic real world. Meanwhile, over on the industrial side, the VRH3 relies on strict vertical in-house integration. This is what enables their incredibly low latency teleoperation, meaning humans can safely guide the robot through hazardous environments using just their natural movement. Because they developed the mechanical architecture, the computing, battery management, and the AI control framework entirely in-house, Vin Robotics makes sure all these systems talk to each other flawlessly. At ICRA 2026, they showed this off by having an operator wear a VR headset with built-in motion capture. The operator literally just moved naturally, and the VRH3 replicated those movements in real time. That is an absolute game changer for remote maintenance or handling hazardous materials.
let's transition over to Section 3, Nvidia's open platform, Isaac G00T. We're looking at a completely different angle here with Nvidia. They decided not to launch a single robot themselves, but instead, they're launching an ecosystem to lift the entire industry up. They basically looked at the whole landscape and realized the biggest bottleneck in robotics right now is just fragmentation. Every lab is out there wasting time reinventing the wheel. So rather than forcing researchers to stitch together disparate parts from a dozen different vendors, mixing one company's simulation tools with another's middleware and someone else's robotic hands, Nvidia is offering a fully integrated workflow. It covers data collection, simulation, training, and physical deployment. This is all built on the Isaac GR0 Pro development platform, utilizing their Unit H2 humanoid reference design. It's essentially a massive shortcut for researchers. It gives them a unified foundation so they can focus on what actually matters, advancing AI behaviors rather than pulling their hair out just trying to get the hardware to communicate.
The really crucial point here is this massive number, 75 degrees of freedom on their 6-foot Unit H2 reference robot. That level of complexity is largely achieved by dual 5-finger tactile hands that unlock highly advanced manipulation research. Think about this for a second. Just getting a robot to do full-body locomotion is already incredibly difficult. But Nvidia paired this platform with tactile 5-finger hands that add 44 degrees of freedom all on their own. This suddenly elevates the robot from just being able to walk around a room to actually being able to execute delicate, complex manipulation tasks using integrated wrist cameras and force feedback.
And to power that absolutely insane level of real-time sensor processing and full-body control, the onboard Jetson AGX Thor computing platform uses a Blackwell-based GPU to deliver 270 teraflops of AI performance. 270 teraflops. That is a staggering amount of compute power to have sitting right there inside the robot's physical body. Paired with 128 gigabytes of unified memory, the Unit H2 can run complex foundational models, process data from its head-mounted stereo cameras, and handle all the logic required for multitasking, all locally. It doesn't have to rely entirely on a cloud connection to function.
And the industry is responding. Top institutions are already adopting this, which really validates Nvidia's strategy that shared, open foundations are going to rapidly accelerate our progress. Heavy hitter groups like AI2, ETH Zurich, and the Stanford Robotics Center have all signed on. As Steve Cousins from Stanford points out, keeping things open and standardized allows the entire global community of researchers to share code, test their ideas, and actually build upon each other's successes rather than starting from zero every single time.
Which brings us to our final stop, Section 4, the future of embodied AI. We've looked at 3 vastly different approaches in this explainer today, but they are all pointing toward the exact same destination: machines that can think, adapt, and physically interact with our environments just as smoothly as you or I do. Whether it's localized dual brains in China managing logic and physics simultaneously, the sweeping ecosystems in Vietnam tackling both domestic and industrial challenges, or massive computational open platforms from Nvidia, the real winner of this race is going to be the one who seamlessly ties all these complex elements together. Because it's no longer just about the hardware, right? The next major leap in humanoids is going to come from the organization that best integrates high-level reasoning with reliable, real-world physical training.
The pace of this industry is getting serious, and the breakthroughs are quite literally happening faster than ever before. So, who do you think will be the first to perfectly fuse AI reasoning with physical reality? Will it be an open-source alliance or a heavily integrated private ecosystem? If you want to keep tracking who wins this race, please make sure to subscribe to the channel, let me know your predictions down in the comments, and I'll catch you in the next one. Keep learning, keep exploring, and thanks for joining me for this explainer today.